For example, when if you want to insert at a specific index which doesn't exist, the code will give you an error. So look at here. After we inserting 7, you see that when I'm actually inserting 7, the list is empty, right? So the only valid index that you can insert to will be 0. If you try to actually insert something at index 1 or anything greater than 0, it should give you an error, right? Because let me actually just show you the size of the system.out. Size is 0, right? At the beginning when you create the list. So only index 0 is valid. If you try to you try to insert at index, for example, 1, the code should give you an error. Let me execute this code and show you this. Okay, you see that it actually just throws an error and telling you that, okay, index out of bound. If you look at the code, you will see that in the method add, I have actually added this sanity check, that if the index that you are going to insert at is an index out of bound, is an index greater than the size, it should actually throw this exception, index out of bound exception. These are just the details of the implementation. I would like you to look at the whole implementation. Although I will discuss about the method add, which is the main one here, but I would like you to mainly look at all of the implementation of the version 0 of ArrayBasedList. Okay, let me just go back here. One more thing that just return this to what was that. One thing that is important for me here is that you can see the implementation here has follows all of those abstraction properties for or abstract data types. So no one basically can try to get access to the items, to the values that you have stored inside the list. For example, if someone tries to access to the data that has been stored in the array items inside the list, you can see that it shows you an error because the field item, the whole array, the data structure that we keep the data, has been defined as private, so it's not accessible from the outside. So you can say it doesn't allow you to access to the data. The other important thing here was okay, as you can see in this implementation, the whole amount of space that I'm taking by using an array is just the array that you are going to keep the data inside that, and just one more variable of type integer. So that's it. This is another advantage of using an array to implement or array-based implementation. So far we have seen this implementation, and you can actually see that the issue with this implementation is that we can only create a list of type integer because I have defined the type of items to be integer. So what would happen if I wanted to create a list of type string, for example? This is something that we are going to talk about it just a little bit later. But before talking about that, I am going to just go back here and talk about the disadvantages of using an array-based list before comparing the version 0 and version 1 of ArrayBasedList. So far, the good The advantages of using an array as the main data structure here was that it allows us to have access to the indexes easily. So let me actually show you again the code. For example, the method get, when we implement the method get, the only line that we need to write is just return items.index. Here, actually, you can see that I again I don't allow access to the indexes out of one. This is a sanity check. So except this, for example, implementing the method get is going to be just accessing to the item at a specific index that you want. So it's going to be an advantage of using an array to implement. The other one is that, for example, when you are inserting at adding to the last index, let me show you the method add without index. It's going to be just added to the last index, the index, you know that where is going to be the last index in the array. That's going to be the index that you stored in number of items. And the other good thing is that we are not getting any space more than the space that we need. Okay, this is also very important for us. We just take the space as much as the array and one more variable, and that's it. But what are the disadvantages of using an array-based implementation? Okay, so here we have, I have actually copied the implementation of the method add. This is very, the font is very small. You can go and look back at the implementation of the add here. The main implementation is this one. You can see that in the method add, in the main method add, that insert the item at that specific index that you want. What you need to do is when you are inserting at some specific index, you have to shift the items to make a space. So for example, if the list is in this situation, that you have already actually stored a couple of items, for example, 7 items in your array, and you wanted to insert another item. For example, you wanted to insert 6 at index 2. So you write it as add 2 and 6. So the first one is going to be the index. The second one is the value that you are going to insert at that index. If I'm going to insert an item here, I cannot just put the item at index 2 because the value 1 is going to be overwritten and I don't want it. So what I need to do is that I have to shift all of the items to the right to make some space and then put 6 here. So everything, that shift has been done basically here. You can actually see that. I will start from the very last actually index, which is going to be this one, copy to the index after that. You can see that the item at index I will be copied at item at index I plus 1. So 5 will be shifted to the right, then 4 will be shifted, then 7 will be shifted, then 2, then 1. Now, so 1 has been safely copied, so I have this space empty, although 1 is there, but I can simply, safely write 6 here. So at the end, when the loop will stop, when I will reach to that specific index that I wanted to put the item there, and then we put the item at that specific index. And just don't forget to increase the number of items as well. So one disadvantage of using array is that whenever you are inserting an item, you have to shift all the items to the right. And what's going to be the time complexity in this case? The time complexity is going to be linear, right? Because it's going to depend on the number of items that you are storing. For example, you have stored in your list. For example, if you have already stored k numbers and you are inserting at for example at index 1, you have to shift k minus 1 item to the right. Okay, so it will depend on the number of items that you are storing. Although if the index is close to the end of the list, the number of shifts are going to be smaller, but when we are considering at arbitrary position, right? So if you choose an arbitrary position, the number of items on average is going to be depending on the number of shifts is going to uh, be depending on the number of items that you have. Because on average, it's just like you are putting at the something at the middle, so you have to shift everything to the right, half of the items at least to the right, and that's going to be depending on n. So in total, we are going to say that inserting an item to some arbitrary position in an array-based list is going to be linear. When you are removing an item from the list, the time complexity is going to be similar to this, because this time, instead of shifting to right, you have to shift to the left, right? Let me actually see that if I have implemented that method remove as well. Okay, yeah, I have it here. You can actually look at your code and you can see that this time, instead of shifting to the right, we are shifting to the left when we are removing an item, because you cannot actually just leave the item out. You have to shift the items to the right to make sure that you are using exactly, you're storing the items from index 0 to, for example, index k minus 1. So removing or inserting to an array-based list is going to be linear. The other disadvantage is that, what do you think would happen if the list is going, the whole array that you have created and you have taken is already full and you are going to insert one more item? What would happen in that case? So the size of the array-based the size of the items is going to be fixed, right? It doesn't matter how big you actually choose it. Basically, you cannot create a very large size, something like, I don't know, 100 million or something like that. Usually, actually, we use, I don't know, something like 10,000 or whatever. Anyway, at some point, it is possible that you fill out all of the items inside the item. All of the spaces inside the array items. So what would happen in that case? You cannot actually simply just throw an error and say that I don't have more space. This is not going to be, a desirable implementation. In this case, if you are using an array as your main data structure and it is already full and you wanted to insert something else there, you have to basically take more space. You have to create another array. Usually we take another array of size double the size of the original one, and we have to copy all of the items from the previous array inside this new array. Then we will continue with the rest of the implementation, just that shift the items to the right and make some space and put the item there. So this part of the code, I write it here in this slide because I didn't have enough space, but you can see that in the main implementation, I have written it as the method expand. Usually, when you are implementing your abstract data type, if you are using an array as your main data structure, you should have this method expand that whenever you filled there is no more room left in the array. At the beginning, just check if the size of the array is already if the array is already full. You call the method expand. You can see that the method expand, I have defined it as a private method. Here I am creating an array of doubles the original size. I will copy everything here, and then I will you can see that this is the name of a new array. I will copy the name of a new array inside the item. So it's just like the reference of the item will be updated. Just be careful. before leaving, you double the size of the max list as well. So now we know that the maximum size of the array is going to be twice, right? So we don't need to expand the array in next time. Okay, so this is going to be another disadvantage for using an array-based list, because the size of the array, whatever is going to be the size of the array, this is going to be fixed, and it is possible that at some point it's going to be full. So, okay, I'm almost done with the implementation of the implementation of a list using an array. Now I'm going to switch to the next, the next version 1. You can actually just create another version as version 1 and import the code which is available on Blackboard. So you have already noticed that in the first implementation, I tried to make it simple for you. So the type of the items in the array-based, this is going to be integer here. But now you can see that you cannot create a list of, for example, strings, a list of another type. But you want to be able to create an abstract data type, which is a general abstract data type. You can put objects of any type inside that. Okay, here is where we need to write our code in a generic manner. Okay, compare the array-based list in version 1 with array-based list in version 0. You can see that I have added something in front of the array-based list as, I have written it as any type and put it in less than and greater than symbols. Okay, in this way, this is actually a syntax of the syntax of Java that shows that no array-based list is going to be a generic code, and any type is an identifier. You can basically write down whatever you want. Instead of any type, you can write it as E. I have seen that in many textbooks they write it as E. In some textbooks they write it as any type. You can write it as type, whatever you want. But the thing is, whatever you write here is going to be written everywhere in the code and showing that the type of the object that you are going to insert in the type of the objects in the array-based list are going to be any type. For example, it can be it can be a string, it can be, you created some objects of, for example, for students, whatever object that you have written. Now you can see that I am writing the type of items to be any type instead of integer. So you can see that I am following exactly the same dictation. Now the type of the items that will be stored in the array-based list will be any type. If you check the main code and if you check the method, the test, okay, now you can see that I have actually, for example, when I'm creating an array, when I'm creating a list of type string, I have written it as a string, just like, in ArrayList from the Java collection API that I showed you the code for that, right? So instead of a string, you can actually create, this is another example, that instead of a string, I can create a list of integers, for example. A list of whatever class that I want. Remember, I told you that you cannot use the primitive types when you are actually writing generic codes, and we need some wrapper classes. Here is exactly the use case for the wrapper classes. Okay, so whatever is the type of objects that you want to store, you will write it when you are actually creating an object of list that you are creating. So I'm not going to go through the details of the implementation here that much. Just compare version 1 and version 0 and see that how we are writing it. I have also actually posted a set of slides about the generic implementation. One more important thing here that I wanted to emphasize is that because we cannot, in Java, because of the syntax error, I cannot write down something like this. If I'm going to take a space for items, I cannot write it in this way. New, this is supposed to be, any type is supposed to be an array of type any types, right? But be careful, any type is not something known for the um, compiler of the Java. So if I write something like this, you actually ideally wanted to write something like this, but Eclipse, basically the compiler of Java doesn't understand any type, doesn't know what is any type. You can see that it's just tell you that you cannot, it doesn't show you that the previous, I mean, in the older versions of Java, it gives you a different error, but anyway, it's telling you that you cannot create an array of any type directly because any type is not a known, it's not like integer, it's not like a known, type for the Java. So we are going to give, a trick here. And what we do is that we create an array of object to take the space and then cast it to any type. So in this way, it's just like we are tricking the compiler of Java to just give us what we want. What else? Okay, one more thing that here is important is that when you are comparing the items, if you are comparing some object, you cannot use the equal and not equal. Remember, we have talked about it in the first class. So in the first version of ArrayBasedList, because the type was integer, I could use equal because integer is a primitive type, right? I think I don't have the, okay. I could write index of in this way, okay, because the type was integer. But I cannot use the equal anymore in this implementation because the values that you are storing in items is going to be some reference of objects. So instead of that, you have to use the method dot equals. Okay, you have to use the method equals. And so if you look at the implementation of ArrayBasedList, index of, you will see that when we are searching for an item, so you are passing an x and you wanted to check that if x is inside your array, so we are using the x dot equals items to compare the items. Okay, this is one more thing that I wanted to emphasize here. The other thing is that, okay, I think I've already actually covered everything about the ArrayBasedList. Just make sure that read the code, compare the implementation between the version 0 that has implemented the ArrayBasedList based on the type integer, and this one which is a generic implementation, and you can store anything that you want here. The implementation that I gave you doesn't have all of the methods. I actually removed some of the methods from your code because those are the parts that you are supposed to fill during the lab for this week. Okay, the Java, again, I wanted to actually say that Java Collection API does have ArrayList. It's not array, I call it our class as ArrayBasedList. That's a little bit different than ArrayList. In Java Collection API, this is called ArrayList. All of the methods that we have written actually are available there, and there are more methods available. You can check the tutorial on Oracle website and check all of those methods. ArrayList is really important and useful class. You can I would recommend that if you haven't used it so far, use it. It's going to be very useful, whatever you are writing. Okay, so I'm going to finish this video here, and in the next video we will talk about the linked list.